One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys and welcome back to this one. Today we are going to be exploring something new on the binary tree series, and this is going to be implementing an Inorder Traversal. So just to give some kind of background context, basically just some kind of context, right? An Inorder Traversal is simply transversing through a binary tree from left to the parent tree, then to the right. So just basically, yeah, that method of transversal. So there are other types. There is the post order where you go from the right to the left, then the primary um, parents, right? So and then there's even another one that where you start with the parents. The name misses me now, but we've spoken about it sometime in this series, right? And yeah, those are the types of transversals we have. And so basically an inner transversal is one that what makes it interesting is that it prints out a tree in a sorted format. That's a binary search tree. It prints it out in a sorted format basically. But yeah, we are just going to be looking at how we print out a tree necessarily, or um in an other manner. So let's just get into it. So we say let C be the root of a binary tree in which nodes have an explicit parent field. Design the iterative algorithm which that enumerates the nodes in order and uses O of one additional space. Your algorithm cannot modify the tree. So basically we have constraints. That's what it's saying in a nutshell. And those constraints are we can't use recursion, we can't use a stack, and we have to use a space complexity of O of 1. Basically that means don't use any list, or yeah, basically don't use any list in the sense, just hold your variables. And yeah, so as we do here, obviously, we will start with the brute force, and we will add a caveat for this one. We're going to also be looking at how we make use of a stack to also solve this problem before then going down to one that encompasses all these constraints, right? So for this one, we will say for test. Okay, so basically that's an import. But yeah, now let's look at the function for a recursive what's it called, solution, right? So we say define another transversal. So we have roots. Basically this could be more appropriately named as current, but because we are going to the recursion, the root is no longer going to be at the root, they node at the top. But to make use of that for this instance, we say if the root is none, return none. So basically we are talking about the base case, right, where we will now have nones at the base. Now we will say go to the left if the lift is not, obviously if we get through this conditional without it being true, we go to the left and we call recursion. So we basically call this function again, go to the left, and when we are done with that, we print the value that is at the current node, and then we go to the right next. And yeah, that's basically it. So that recursion carries us through down to the bottom, printing out every node in that another manner, and then we go ahead to call our function here. So that's it for this one. So next up we are going to be looking at this graphically and to see how we move through this guy creating this in order list or prints, right, from a graphical point of view, giving us a clearer and more ready understanding of the concept recursively, right? And that's what we are going to be doing on the next video. Muchas gracias. Auf Wiedersehen. Cheers. Bye.